Neuroscience reveals our brains default to familiar patterns, creating mental ruts. Studies show 60% of daily thoughts are repetitive. This cognitive efficiency comes at a cost. It suppresses divergent thinking essential for innovation. Functional MRI scans demonstrate how habitual thinking activates limited neural pathways, while creative tasks engage broader brain regions. The first step to rewiring is recognizing these self-imposed constraints that shape our perception and problem-solving abilities. Research from Stanford University shows moments of doubt trigger the brain's salience network, the neural switch that shifts attention from automatic to conscious processing. When we question assumptions, the anterior cingulate cortex activates, increasing cognitive flexibility. This biological response explains why innovators often report aha moments emerging from periods of uncertainty. The flickering light bulb metaphor represents this biological shift where new synaptic connections begin forming at 2 to 3 times normal rates during such epiphanies. MIT's Cognitive Science Lab found exposure to unstructured information increases creative problem-solving by 32%. Chaos triggers the brain's noradrenaline system, enhancing pattern recognition. The prefrontal cortex temporarily disengages, allowing novel associations between seemingly unrelated concepts. This explains why artists and scientists often report breakthroughs during messy, exploratory phases. The brain literally rewires itself, with dendritic spines forming new connections within hours of chaotic stimulus exposure. UCLA brain imaging studies reveal that just 30 minutes of creative activity daily increases gray matter density by 15% in 8 weeks. BDNF, brain-derived neurotrophic factor, surges during novel experiences, acting as fertilizer for neurons. This scene visualizes the biological truth. Each new thought physically alters brain structure. Axons extend like branches, synapses strengthen through use, and myelin sheaths thicken around frequently used pathways. The brain's plasticity continues throughout life, debunking the myth of fixed intelligence. Cambridge University identifies cognitive disinhibition as the neural state preceding creative insights. When the brain's inhibitory mechanisms relax, normally filtered ideas reach consciousness. EEG readings show gamma-wave synchronization across distant brain regions, milliseconds before breakthroughs. This scene captures that pivotal moment when persistent effort meets neural readiness. The glass wall represents the brain's default mode network, giving way to the executive control network's innovative capacity. Brown University's research demonstrates how play activates the brain's reward system while lowering fear of failure. Dopamine levels rise 25% during experimental activities, enhancing both motivation and cognitive flexibility. This neurochemical state explains why children learn faster. Their brains remain in exploration mode. Adults can recreate this by engaging in low-stakes creativity, which stimulates the same ventral striatum activation seen in childhood learning. The hands represent the embodied cognition principle. Physical manipulation sparks neural innovation. Harvard's Innovation Lab found that 73% of breakthrough ideas combine previously unrelated concepts. This associative thinking relies on the brain's temporal lobe making unexpected links. Functional connectivity MRI shows increased communication between default and executive networks during such synthesis. The floating thought bubbles represent how innovators mentally rearrange information, not creating from nothing, but combining existing elements in novel ways. This cognitive process underlies everything from artistic metaphors to technological inventions. Neuroscientists identify flow state by distinct brainwaves, theta waves in prefrontal cortex indicating relaxed control, coupled with beta waves in sensory areas, sharp focus. This paradoxical combination explains why flow feels both effortless and highly productive. Stanford's research shows flow increases creative output by 400%, while subjectively reducing mental effort. The whirlwind represents how external awareness fades during deep creativity, as the brain's self-monitoring systems temporarily quieten to allow unimpeded idea generation. Columbia Business School studies reveal that creative solutions often emerge from constraint reframing, viewing limitations as opportunities. This cognitive shift activates the brain's right inferior frontal gyrus, associated with conceptual expansion. The transforming cityscape visualizes how innovative thinking literally reshapes environments. Remarkably, fMRI scans show that simply imagining creative solutions strengthens the same neural pathways as physical implementation, proving thought itself is a transformative act. Princeton's Social Neuroscience Lab demonstrates how creative thinking spreads through communities via mirror neuron activation. When individuals observe innovation, their brains simulate the creative process, making them 40% more likely to attempt similar breakthroughs. The glowing connections represent this neural resonance, ideas propagating through social networks, much like electrical impulses through brain tissue. This explains humanity's cumulative creative progress and underscores our shared responsibility to maintain environments that foster cognitive flexibility.